Hi, everyone. I am going to take you through the lesson number 10, which is on chemical reactions. And in order to do this, you need to go into lesson number, where were we? Lesson number 9, okay? And you'll see in lesson number 9, there's 1.4, right, which is our chemical reactions. There's a few extra icons here that you don't see, and that's okay. So we're going to full screen this. You should always full screen these resource notes. It's too small, okay, what is listed there on the D2L site. And this is what we did in lesson number 9. We talked about balancing chemical reactions. And so you should have gone through, made some notes for yourself as I took you through the actual lesson note. Definitely try this little activity from PhET. It's excellent, okay, for practicing balancing reactions. And balancing reactions is really important, particularly when we get into our third unit. Our third unit is a unit that is based on mathematical concepts of chemical reactions. And if your formulas are not correct, if your coefficients when you balance are not correct, it will really mess up your math. So it's really important that we understand and know how to balance chemical reactions. So you're going to scroll through. Hopefully you've tried all this. Even though I go through and I'll do a lesson note for you, you should always come back to the main resource note here. And they have really great little tasks, right, to show you or get you to practice the concepts that we learn. So I come in and I can make notes for you here. And this is where lesson number 9 ends. This is on balancing. And here we go today. We're going to start lesson number 10, which are types of chemical reactions. Okay. So in grade 10 science, you would have learned your types of chemical reactions. And this occurred whether you took academic grade 10 science or applied grade 10 science. And there are 5 main reactions that you should have learned. And I'm going to go through each of these 5 types with you. Now, notice here that they are not actual reactions. They are just sort of generic, symbols that kind of represent what happens to the elements in the compounds. You have a summary note that you should be following along with here in this lesson and giving examples. Okay, so these would be your generic chemical reactions with just some, rough trends that are happening. To get the actual examples, you should be getting those in the little video that is attached just below. And I'll show you where that is. So the first type of reaction is a synthesis reaction. I tend to use the term synthesis rather than combination, but people do use combinations. And what will happen here is you will take 2 reactants and you will combine them. This is why they call it a combination reaction, into one product. Okay, so sometimes these A's and B's are just elements that come together, and then you would use crisscross rule and come up with the formula. Sometimes these A's and B's could be an element in a compound. Sometimes they could be 2 compounds. It kind of depends, okay? But generally, you're always looking, for one product in a synthesis reaction. A decomposition reaction is just the opposite. Like, notice what's going on here, okay? And this is the thing with chemical reactions. There are patterns that you should be able to pick out and identify in order to classify types of reactions. So decomposition is just the opposite. You take your one reactant that is a compound and you break it down or decompose it into whatever makes up that compound. So typically it's 2 elements. Sometimes it could be 2 compounds, like 2 simpler compounds. The important thing is that you recognize that a synthesis reaction makes one product. A decomposition reaction has one reactant that breaks down. When we look at the next 2, they're kind of similar in that they will cause replacements. Okay, so single replacement reaction or double replacement, or I prefer the term single displacement reaction or double displacement reaction. And they're kind of similar, but they are different. In a single displacement reaction, you're going to have some type of element on its own, and you're going to have a compound. Okay, so you'll always recognize it, element and compound. And depending what that element is, so let's say the element A is a metal, then in my compound, we always know metals are placed first and non-metals are placed second. So this element A will be a metal that will kick out the corresponding metal in the compound. And then you'll see that element stay by itself on the product side. And then A will form a new compound with C. Okay, so this is why they call it replacement or displacement. The single element just takes the spot of B, and then B is kicked out and A forms a new compound. Now, usually with single displacement reactions, we need to know, can that element, be able to kick out the corresponding element in the compound? And this doesn't always happen. And in the video below, they kind of go through that. There's something called an activity series of metals that will help you determine that. We actually are not going to worry about that in our course. Okay, so just assume that any metal that I give you will be able to kick out the corresponding metal in the compound. For a double displacement reaction, what happens here is you'll have two compounds, and then the outside ions will go together, okay? So they're going to displace each other. They're going to replace their positions. A is bonded to B initially, but then what happens is A will actually be able to find D and form a new compound with it. So I always say outside ions go together, and then inside ions go together. Okay. And remember, we always put the metal first and the non-metal second. That's what they're showing you here. And then in this compound, C would be a metal and B would be the non-metal, and inside ions go together. And this is why they're putting C first here. Okay. Because C was first in this compound. He still has to be first in the new compound that he makes. And don't forget, all the while, you got to balance these, okay, if you need to. The last type of reaction is a combustion reaction. And combustion reactions are kind of unique, and they don't really go with the other four that are here. And notice what's happening here. They have CXHY. So we know that these little X and Y letters refer to the number of atoms of each carbon and hydrogen in this compound. Well, you can have all kinds of different combinations of carbons and hydrogens together. In fact, that's our next unit. Our next unit focuses on organic chemistry, and we deal with all these carbon and hydrogen-based molecules. But it doesn't matter what the ratio of atoms are. You're always going to react it with oxygen in a combustion reaction. And you always make carbon dioxide and water and heat. Okay, so you'll feel a lot of heat coming off that reaction whenever you combust something. This is an example of us, if we're in science class, if we light a Bunsen burner, we do a combustion reaction because the gas coming out of the Bunsen burner is actually CH4. It's methane gas, and it reacts with oxygen in the air, produces CO2 and water, and we feel the heat coming off of it. If you burn wood or combust wood will have a formula that will have some sort of, large number of carbons and hydrogens, and you always produce the same two products in a combustion reaction. Again, the difference between molecules will just be in your balancing of them. So these are your 5 main types of reactions, and you should get down, again, just these general formulas for each of them. And then what I want you to do is watch this video, and this video takes you through the 5 main types, and it gives you specific chemical reactions. So you can actually write down the chemical formulas and the balanced equations for each of them. Okay, so make sure you watch this so that you can practice that. Then as you go through the resource note, they're going to get you to practice. I just love the resource note because I think that they do a really great job of getting you to classify the different types. So there's 5 questions here. You take a look at the chemical reaction, and then you say, is this combustion? Is this double displacement? Is this synthesis? Is this single displacement? Based on what you see here and based on the pattern, which one does it match from up here? Okay. And then you can select, you can submit, and then you can try the next question. This is also really, really good. Okay. There's a little practice session here. And if you click on start, okay, it will take you to this different website, and it'll tell you an introduction. You can start, and then it'll review the different types of reactions. And you can pick, do you want, for synthesis, show color, coding, okay? And then they'll give you an example, okay? And what they're doing is they're just coding the atoms to keep to keep track of them. Okay. Here's another example, right, where you can do it with a markup. And then you can move on to the next example for decomposition. And then they're going to go through examples for you. You can click to these different tabs. Here's coding and classifying. Okay. So again, you can classify these reactions. You can select the coding. So for example, if you want to color code magnesium as red, you apply the markup. And then you can do that there too, just to keep track of your atoms. Okay. They do a great job with this particular activity. And then this is the most fun. Okay. You can predict the products of these reactions. So here's two single elements together. You know, which type of reaction is this? Well, two single elements by themselves is going to be a synthesis reaction. You can submit and see if, you know, just if you want to test yourself on the type of reaction, but you should also try here, you know, what would be the compound that gets made? Well, magnesium and iodine would come together. And do not forget about your rules of ionic compounds. Magnesium has a charge of 2. Iodine has a charge of 1 when it's in a compound. We apply the crisscross rule, and then you can compare your answer there and see if you get it right or not. Submit this. Everything's good. You can move on to the next question. Okay, these are really, really, really good. So then we can go back to the main resource note here. Let me full screen this for you again. You're going to try that. And then again, here are some extra practice with reactions. Okay, so they're going to get you to come up with the different products, and then that's good. That's all that I want you to do for today. Okay, there are 2 worksheets that I have attached in the content section where I give you a bunch of different reactions and you can classify them and balance them. Make sure that you practice that as well. Okay, let me know if you have any questions.